Okay, so I saw that there are new guests, so I will introduce myself a bit once more. I am Yuri Temchuk, but you can call me Uko. And I am a master student and a software engineer from Ukraine. And right now I'm doing my internship in remote team. And yeah, I want to give a talk about the project I'm working on. So, who has seen this picture? Okay, so you followed Dora's presentation and you know how cool it moves. Now, what I want to look particularly on, you see that in the middle you have a model. And I want to talk a bit about the model of Moose. And Moose uses FAMX. And what can we model with FAMX? So we can have packages, and packages apparently can have classes inside. And if you look inside of a class, then there are some methods. And we can go even deeper because we have some variables in methods, so we can have parameters and local variables. And FAMX is really cool because, you know, we can even have more fancy stuff like accesses to a variables or invocations of the methods. But the main question is, if FAMX is so great, then what's the problem? And there is indeed a problem. For example, if you want to calculate some metrics of the code where you need a code structure, or you want to check some rules like small int, you once more need a code structure. Or if you want to detect duplications of a code in some fancy way other than checking just the strings, you once more need a structure. And also you can work on representing your code in some other way, but to represent it in the other way, visualize it in some way, we need a structure once more. And there are also some really crazy people that want to convert from one language to another. And we once more need the structure. So, as a result, FAMX simply can't handle that. Because we need ASTs. We need 3 models of our code. And that's where my project starts. And that's what the FAMX is for. It's where the FAST is for. It's FAMX AST. So, as you know, FAMX should give support for different languages, and you should be able to extend it to different languages. So I tried to do something with the FAST in that way also. And from now on, I worked on Smalltalk and on Java, and just to give a highlight of the progress. So Smalltalk is quite cool implemented, while I just started to work on Java, but we still can have some nice functionality to show how the FAST project works. And also I want to highlight that FAST still looks for whole set of tools like importers, because you need something to create that model itself, and then analysis of that model, of course. And I want to talk about each part now. So first are importers. And the main idea of importer is super easy. You take a source code and you generate a tree model, you know? Not so bad. And we want to do this on demand. So we won't just generate everything in one run with FAMX, because you already have some problems that you can't fit general FAMX into the memory because of 32 bits and, you know. With AST data, it just explodes. So we really need a tool where we take a source code and generate a tree model. And I was using Petit Parser in my project. And that was a bit a tough decision because, for example, for Java in FAMX, they use Variant that is really awesome tool, but how it works, you take some code, you pass to it, to external tool written in Java, then it generates an MSC file, and then you read an MSC file and import it into Moose. And petit parser looked a bit better because you can take just a source and convert it and have everything in Smalltalk. And also I moved Smalltalk to use a petit parser, so it was quite nice. But now let's talk more about the model itself. So here is a general diagram of the main components that we say that they are common for most of the languages. And you can focus on the behavioral entity. That means the entity that has a behavior, some function or method or block in Smalltalk. Then we have statements that are statements in a code, like return statement, if statement, loop statements, or just expression statement. Then we have expressions, things that are in a code that have value in them, that return a value. For example, a message sends, they return a value, and even some literals, they are actually values, so they are expressions. And then one more thing that is really nice is these two little entities, and that are bindings to the famix itself. So when we are in the fast model, browsing AST, we can always go to famix and see what's on that level, and vice versa. And that's really nice. And also I want to highlight these strange styled arrows that I want to make just a different arrows to tell that when we will have some reference from statement to a method, then we will have the reference back, because we want to be able to traverse a tree from bottom to the top. And the same with expressions. If we have a reference from the expression to other expression, we also want to have a reference back. And I will show you on the next slide, that is Smalltalk, AST. And so here you also have behavioral entities that are extended with the block definition, because we need blocks in Smalltalk. And also we have statements that are extended with Smalltalk expression statement and Smalltalk return statement. And in general, everything else is expression. Also, we have once more binding to famix, and here we have one more binding, this one. So the message send is binded to the famix invocation. We have two connected. And as you remember, I was talking about this uplinking. They are represented in the things underlined. So whenever we have reference to an expression from a statement, we have a reference back. And so that's a diagram of Smalltalk. One more thing that should be interesting to you is that I changed actually how the Cascade is modeled comparing to refactoring browser. So in refactoring browser, you have a Cascade node. Then the Cascade node has a messages in it. And each message, of course, has arguments that we do not care about right now. What we care about is the receiver of the messages. And the receiver is connected to the first message. Of course, you can access it from the Cascade, because Cascade can ask first message, what is your receiver? But that's a bit strange, you know, because how I understand Cascade is that you have a receiver and then you send messages to it. So what I have done in my model, I moved receiver just to the Cascade, and so it's uniform now. And of course, receiver can be accessed by the messages, because they can ask Cascade what is the receiver, and that's it. Now a bit about Java. So before showing Java to you, I want to make a little comparison, because right now Java is implemented just with cherry-picked nodes, just to have some implementation to test how the analysis work on it. But in general, if you compare amount of nodes in the languages, it's like that. So in Smalltalk, you have only 2 statements, while in Java, you have about 15 statements. And in Smalltalk, you have 15 expressions, while in Java, you have 30 expressions. So that's enormous amount of work to just model it. And also, I have done some funny comparison of the languages, and you can check them on my blog, because I can't show here everything. But it's quite nice. Uko on code, blogspot.com. And so now let's move into Java. So that is the current state of Java. And as you can see, we still have behavioral entities. We have statements, and right now to statement, I added the variable declaration statement and while statement, so we can have some sort of loops that generate cyclomatic complexity and things. And also we have expressions that I just added an infix expression. That means the expression where you have 2 hands and something between them, like instance of, equals, less equal, more equal, something like that. And so now I want to show you how it looks like and what you can use indeed. So we have Moose here, and let's go into Moose panel. Is it a good size?
Yeah. Yeah.
Cool. So I have loaded already some models, and this is a Smalltalk model, and let's go directly to methods. And for example, there is a fancy method called middle of and that is super simple, just calculating average. But what's the main idea? That you can ask the method to generate fast, and after that you have a fast behavioral entity inside your famix method. And so you can check it out, and it has a local variable sum, and it has 2 parameters a and b, and then it has 2 statements, and it's an expression statement and return statement, and you can explore this, an expression statement, and expression statement has an expression that is assignment expression, and the assignment expression has a variable that is assigns to, and it's sum, and it assigns another expression that is a message send, and so it's a message plus that has a receiver A and the argument B, and so you can browse it in all that way. And as I told her already, it's connected. So if we go back and we look outgoing invocations, and indeed here we have 2 invocations. So we invoke plus and division messages, and let's check out plus. And you see you have a link to a message send from fast, and then you can go to message send and browse the message send, and you can go even to parent expression, and you can see that this is assignment expression, and then you can go once more to parent statement, and so this way you can check, okay, I have invocation, I want to know, is it, one moment, is it in the if block, if we are in Java, for example, or something like that. Doru, you had a question?
So the famix invocation object, is it the same from the model? You showed an invocation between whatever.
Yes.
No, that one. Yeah. That. Yes.
So these are invocations of a famix.
Yes, I know. But the question is the instance of this one already, is this the same that is already parsed by the visual word parser?
Yes.
By the Smalltalk parser?
Yes.
How do you match that?
Okay, that's a fancy part. So I rely on the order. When I need to generate a fast model, I take all invocations.
In the same order?
Yes. So that can be a question for an investigation, but yes.
Are you doing the same for accesses?
Not really, because what I'm doing, and I will tell it a bit later, but I'm linking fast variables to famix variables. And so more or less they are linked. So you can just, okay, let me show it. As I told, we have a message sent, and we have arguments b, and it's a variable. And then we have a famix named entity. And then we arrive at the famix once more. And so this is more or less...
we should treat it the same. Accesses are the same as invocations.
Yeah, I know. So it can be added easily. It's just... And also a really simple Java demo. So I have a very funny class that is like that. It has some really simple methods because my grammar is simple. And let's go to the methods and let's check. I need the names. Okay, while. It's quite nice method. So it has some indented while statements. And if you look at that, by the way, I have fancy stuff. You can press, okay, let's do this a casual way here. Generate fast. And now we have 5 statements here, and this is really nice. We have a variable declaration, 2 while statement, 1 more variable declaration, a return statement, and so you can browse it next. So what is the fun thing? You can just click here, go to fast, and generate fast for all methods, if you want. And it doesn't take a lot of time, but you can do that. Okay, so let's go back to the presentation. Now I want to talk a bit about analysis. We don't have that much, but they are anyway nice, how we analyze our model. So first of all, what I think is important is symbol resolution, because when we have a code like that, I showed you this method, middle of, we generate a tree model that is something like this. So you have a method, you have parameters, local variables, statements, and you have a tree. But when you look at the model, all the sum nodes are just nodes that know that their name is sum, and that's it. But we know that is one variable, and that's what is important. And so what we want to do is we want to have some meta variables and that are unique, and then maybe they can hold some meta information, like for example type of a variable if it's typed language, and so then we just link to them. And the question is, how do we do that? Right now it's done in a really simple way. So we have a scope that has a simple dictionary that has keys as strings with names of the variables and values as these meta variables. And we have also a parent scope, because for example for method, parent scope is a class, and for class a parent scope is a package, for example. And so what we do is we ask scope, can you give me a variable for this name? And he checks in a dictionary, if it's not finding it, it goes to a parent scope and asks in a parent scope. And for Smalltalks it works really great. For Java on the level of method it works really great, but I didn't have time to test it a lot more, because for example I think that you need to take into account private access modifiers and so on. And one more fancy analyzers are metrics. And right now we treat metrics as an amount of something in code. And something can be, for example, some nodes of a kind or amount of cyclomatic complexity in code. And how do we do that? Right now it's really simple. You know, in collections you have a really good method called inject something into a block. And what it does, it goes over the collection and it takes the initial value that you injected and then in a block you can accumulate it. We have the same for our model. We have a visitor that is a collector visitor, and you can tell it, make a new collector visitor with the seed and the block that will accumulate it. And so in the block we can check if this node is what we are looking for, then add it to the collector and then we can get it. And for example, for cyclomatic complexity, how do we handle that? We tell that each node has a cyclomatic complexity contribution. And for example, class contributes 0 complexity, and return statement also contributes 0. And if we go to if statement and while statement, they contribute 1. And if we have a message send in Smalltalk, then the message send calculates, because, well, it's a hard part how to calculate cyclomatic complexity in Smalltalk. But for now on, we just tell that, okay, we know that there are some often used methods that generate it, and we have a dictionary of them, and so we just check that, and it's calculated on the go. And if we will have some fancy things, like for example, you know, in Python, they have else part in for statement. It's really nice. So if we will implement that, we will just tell that it returns 2, and that will work. And in general, that's all about fast. So you can contribute to that. It's on Smalltalk Hub, on GitHub via file tree, and it also runs on the CI server, so you can get it from there. And you can contribute even more probably by using that and telling what is bad and what you want in there. And also we made 2 proposals for a Google Summer of Code. One is implementing a full Java model for fast. And the second is developing some nice visualization for tree models. So also, if you can find some nice students that will want to work for that, I will be thankful. And now the last thing, as I told at the beginning, I am doing internship in R mode, and it ends in a week and I will be leaving. So this presentation is probably my grand final. So I want to thank some people. First of all, I want to thank Stefan Dukas, because he was the one who replied to my interest in Faro, and he helped me to start my master project as fast. And also I want to thank Nicola Anquetil, that wasn't here, but he spent a lot of time supervising this project, and he was contacting with me by email while I was in Ukraine and stuff. And also I want to thank a lot Armod team, because it was the best team I ever worked with. And so thank you guys. And yes, this was fast metamodeling ASTs. Thank you. And do you have any questions?
What's the difference between so is there a fast for Java or not?
So there is fast for Java that works on some super small subset of Java methods. And in general, it was just created to test if we can run a cyclomatic complexity, if we can. The main concern is symbol resolution. So by having while statements and statement blocks, we can already try to resolve symbols in Java, and also we can try to do that. So that was the main idea why I was pushing Java so fast.
So what happens if you have a method that is not covered with the if or something like that? Is it just going to ignore that?
Ah, okay. So yes, you mean in Java, right?
Yeah.
No, it won't ignore that, because how it's done right now, Petit Java was a really nice project because it has already full grammar definition for Java. So right now, parser parses every code in Java, but it just generates an arrays. You know how Petit parser works. And all I had to do is create classes and subclass the parser and redefine the methods to put the array data in classes. But right now, if it finds something else, you just get an array there. So it's how it works. But if I didn't have a Petit Java at that point that it could parse actually every Java code, probably island parsing will be really good in there. So
you just need to flesh it out a bit more.
Yeah. But that's the main idea of the project. Because actually developing thing for Java means two parts. First is fast, and second, that is before the first one, is Petit Java. Because you need to develop a parser a bit also. Yes?
So maybe you talked about this and I didn't get it.
Yes.
The idea of Phonics is to be language independent.
Yes.
Right? So I saw that I would imagine that fast is somewhere still language independent, but closer to the AST. So I would imagine that you want to only capture those things that are common through all object-oriented languages. Is it like this?
So what I was telling is that we want to develop some core AST that has most of the common properties of the languages, and then if you want to define it for some specific language, you just add additional nodes. And for example, right now I have a very strong separation because I have a Smalltalk return statement and Java return statement, and in fact they have the same meaning. So my idea was to implement something and then sit and look in it and reason, and then yes, probably I will merge them, but it takes time. So it's work in progress, and I showed the current state of the progress.
Usually, I think you use visitor to visit the tree. So
yeah, but that's
for Java return statement, you can say accept to statement, and same for the Smalltalk return statement. So your visitor will have to end up in the same method, right? So
yes, but
it not really matters whether you have two subclasses.
And it depends, because if you have the back pointer, and that back pointer can be one parent or another, and there it's not really polymorphic, then this is where you might have a problem.
yes, in fact, what is fun also is that Famix is, or better call that Fame is somehow strictly typed.
No, it's not. Only if you want it to be.
Yes. So the question is, do we want to do that? Because if we annotate it with pragmas, and what was my problem in Smalltalk, you can have variable either in assignment expression, where something is assigned to a variable, or in variable expression. This means that everywhere where you can have an expression, you can have a variable. And so if you want to tell what is the parent, you need to define that it can have two parents, either parent assignment expression or parent variable expression. And the question is, should we follow that, or should we just tell that it has a generic parent and we don't define what is kind of that parent? Toru, do you have some suggestions?
No, I was just looking at some code.
Okay. So, any more questions? If no, then thank you.